How many of you feel that when you sit for an exam, this happens? I did not study for this. Why is my mind blank? Why is there a hole in the ceiling? This is not in the syllabus. Am I in the right exam hall? Who are these people?
Hey guys, this is Jeremy J and welcome to Illustrated Maths. We are at our last video on functions, which is top 10 questions on functions.
In this video, we're going to choose the top 10 function questions from IGCSE, SPM, and Cambridge O-levels. I ranked the questions based on three criteria: difficulty, psychological effect, and the time taken to complete them. I would love to hear your comments about whether you agree or disagree with my picks. Just comment below. Let's begin.
Number 10.
Starting off our list is a question from Cambridge O-levels, November 2018 paper. We all know that inverse function is one of the not so easy topics. But what makes this question fall into my top 10 is that there are not one x's, but there are two x's in the equation. I believe you guys remember how hard it was when the x is below in my denominator. But now in this question, I have an x above in my numerator and also below in my denominator. Let's see how to solve this.
Given that fx equals to 2x plus 5 over 3x, find f inverse x. We substitute fx as y, and we move 3x over to multiply with y. After that, we shift over 2x to the left to become minus 2x. Okay, pay attention closely to this. This is where the trick is. We factorize x out from our equation on the left. Once we have successfully isolated our x, we can move the rest of the term over to the right. So the answer for our f inverse x is 5 over 3x minus 2. Number 9.
Sometimes we have questions with additional stuff added to the basics that we have learned. But what this question did was it added multipliers, it added unknowns, and it added an equation inside another equation. But we can solve this question by just doing it part by part. Let's have a look.
Given fx equals to 2x minus 3 and gx equals to 1 minus 3x, find the value of m if f m plus 2 equals to 1/7 of g5. The question wants us to find the value of m. Let's write down the equation again. F m plus 2 equals to 1/7 of g5. Before we substitute m plus 2 and 5 into our respective functions, we first write down what's fx and gx. Now we replace our x with m plus 2 on the left and 5 on the right. We slowly simplify our equation until we get the answer for m. Workings for the exam marking scheme is shown on the right here. Number 8.
Many people refer to the SPM 2019 paper as the nightmare paper. In all honesty, this question is really simple, but it messed with the minds of the students by deliberately giving it a probability feel. 90% of students will try to avoid probability question. So when the moment they saw this question and it being the first question didn't help, the students gave up here. So this is a perfect reminder for us. Never judge a question before you have read and understood what the question wants.
3 dice of different colors are thrown. The numbers obtained by red, yellow, and green are 6, 6, and 3 respectively. Draw an arrow diagram to represent the relation the colored dice thrown to the numbers obtained. Hence, state the type of relation. Is this the relation of a function? The numbers obtained by red, yellow, and green are 6, 6, and 3. So this statement tells us that red, yellow, and green are the inputs, and the result or the output is 6, 6, and 3. Red and yellow both gives us 6, and green gives us 3. So this is a many to one relation. Since the output is 1, therefore this is a function. Number 7.
One of the hidden or unseen enemies for maths is time. Students often underestimate the importance of time management. And we are oblivious to the fact that exam papers are tailored not just to test our knowledge, but also to test how fast we can solve a problem. Like this Cambridge O-levels November 2019 paper.
Given that fx equals to the square root of x for x more than 0, and gx equals to x plus 5, also for x more than 0. Identify each of the following functions with one of f inverse, g inverse, fg, gf, f squared, or g squared. The normal approach students will take is to find the equation for each of the functions here. There are 6 functions. So after finding all 6, students will compare those answers with the equation given. That method is not wrong, but it's a bit inefficient because there are only 4 questions, but you're going to find 6 answers. Let me show you another method that will help you breeze through this question and save you time. The first question is square root of x plus 5. If you look closely, square root is the function of f, and x plus 5 is the function of g. So this looks like the function of g is put into the function of f. Therefore, it is function fg. Question 2 is x minus 5. We know that this has nothing to do with function f because function f is square root of x. It looks something like function of g, but instead of plus 5, it is minus 5. So we know that this is the inverse. Plus becomes minus for inverse. So therefore, the answer is g inverse. The third question is x squared. Again, we know that square is actually the opposite of square root. So therefore, the answer for this question is f inverse. The last question is x plus 10. This is a similar equation like your function g. They are both arithmetic equation, but there's plus 10 here. Function g is just plus 5. So we know 10 is actually 5 plus 5. So this looks like two function g's. In fact, it is. It is function g squared. Number 6.
At number 6, we have IGCSE March 2019 paper. Exam questions often try to make the question seem harder than it actually is. For example, in this paper, the question asks, how is it something a function, but when you inverse it, it's not a function? So this creates like a paradoxical, mind-blowing effect for the students. But in actual fact, you don't have to worry about all that. You just need to find the inverse, and once you've found it, the answer is obvious.
Given that gx equals to 6x to the power 4 plus 5 for all real x, explain why g is a function but does not have an inverse. Let us substitute a few values to see what we get. We put in 2 and we get the answer 101. We put in -2 and we also get the answer 101. For every input we put in, we get only one unique answer. But there are a few inputs that give us the same answer. So this is a many-to-one relation. Therefore, g is a function. Now let's try to explain why g inverse is not a function. We substitute gx as y and we rearrange the equation. We get the answer g inverse x equals to the fourth root of x minus 5 over 6. Fourth root of a positive number will result in two answers, just like square root, a positive answer and a negative answer. So this is a many-to-one relation, and this is not a function. Therefore, gx does not have an inverse. Number 5.
Okay, I cheated a bit here. This is not from any of those three examinations. This is my own question. But I feel that this question has stumped most of the students. When we do questions and halfway through it, when we get stuck, we have a mental block. We start off the question with confidence, but the moment we hit an obstacle, we don't know what to do. So please remember, when you face this situation, always go back to the basics. Not just the basics of functions, but the basics of algebra itself. Let's have a look.
Find the inverse function for the following equation. Fx equals to 1 plus 2x over 3 minus x. We approach this question just like how we approach all of our inverse function questions. We replace fx with y, and then we bring the denominator from the right to the left and multiply into y. Then we move 2x from the right to the left to become negative 2x, and we move 3y from the left to the right to become minus 3y. If you see there are many negatives in this term, so what we can do is multiply negative on both sides, and all the negatives will turn into positive, and the positives will turn into negative. So the trick here is to get all the terms with x on the left, and whichever terms that do not have x will end up on the right. We factorize x out, and we move the term y plus 2 over to the right. We get the answer f inverse x equals to 3x plus 1 over x plus 2. Number 4.
At number 4, we have a question from IGCSE, November 2017 paper. This is almost like the previous question, but it takes it to another level. It asks specifically why a range of a particular object does not exist. The question is testing us how well we understand objects, range, and composite functions. And understanding these components will help us answer these questions easy.
Find the inverse function for the following equation. State the range of g, then explain why fg1 does not exist. For questions that involve range and domain, we need to figure out what's the maximum and minimum values. So to find the range for g, we need to substitute the smallest value for x, which is 0. We then substitute a few other values to see the behavior of the equation. The smallest value we see here is negative 1 over 2. So the domain for gx is bigger or equals to negative 1 over 2. The second part of the question wants us to explain why fg1 does not exist. Function fg1 can be further broken down. Function g1 goes into f. g1 gives you the answer 0. But since the domain for fx is x is bigger or equals to 2, therefore 0 is not allowed in this function. So fg1 is invalid because g1 gives us the answer 0 and the domain of x is more or equals to 2. Number 3.
One aspect of maths that many maths-loving people hate is drawing. So when it comes to graph, our minds automatically tries to reject the question. Adding in a modulus equation graph makes it even worse. But if you try to look past that and just focus on the question, you will find that it is not that bad. Let me show you how.
The diagram below shows the graph of function fx equals to the modulus of 1 minus 2x for the domain x from negative 2 to 3. Find the object of 7, the image of 3, and the domain of fx from 0 to 5. To find the object of 7, which means 7 is my image, I just have to look at the graph, and the answer is 4. The image of 3 means 3 is my object, so I substitute 3 into my equation, and I will get the answer 5. To get the domain of fx from 0 to 5, I draw a horizontal line on the y-axis at fx equals to 5, and I see where the lines intersect. The lines intersect on the left at point negative 2, 5, which means my x value is negative 2. From the previous question, we know that the image of 3 is 5. So the right side intersection is actually 0.35 with my x value being 3. The minimum range for my fx is 0, and if you look at the graph, 0 actually falls between negative 2 and 3. So therefore it does not affect my range. So the answer for my domain of fx from 0 to 5 is x is from negative 2 to 3. Number 2.
Although this question from IGCSE November 2019 paper involves other topics, it is technically a function question. It combines two topics actually, functions and indices. But good news about these type of questions is that they pick mid-level difficulty for each of the topics.
It is given that fx equals to 3 multiplied exponent to the power of 2x plus 1 for all real numbers for x. Write down the range of f. We approach this question just like how we approach any question that asks us for range. We substitute the smallest value and also the biggest value to see the result. We first substitute negative infinity into x. We know that anything multiplied negative infinity is negative infinity by itself. So we will get exponent to the power of negative infinity. Any number with a negative power is 1 over that number with a positive power. Exponent to the power of infinity, it is also infinity. 1 over infinity it's like taking 1 dividing a very, very huge number. If you do that in the calculator, you will get a value that is almost 0. So 1 over infinity is actually 0. So the whole exponential term becomes 0, and we get the answer 1. We don't really need to show our workings for when x is infinity, because this will give us an answer of infinity. So the answer for our range for f is larger than 1.
Number 1.
We are finally at number 1, and in my books, this is the most difficult question from all 3 papers in the last 5 years. This question combines not 2, but 3 topics: indices, logarithms, and functions, of course. And the only way to solve this question is to master all 3 topics.
It is given that fx equals to 5 multiplied exponent to the power of x minus 1 for all real numbers for x. Find f inverse and state its domain. Let's find the inverse first. We substitute fx as y, and we rearrange all the equation to the left. If you want to make x the subject matter, and x is the power, you need to use log or ln to bring x down. For exponential numbers, you use ln. You ln both sides, and when you ln exponent to the power of x, you get x. So we get the answer f inverse x equals to ln x plus 1 over 5. Log or ln only works for numbers that are 0 and above. I've demonstrated here, if you substitute a negative number, you will get a math error. Since the value of ln cannot be negative, so x plus 1 must be bigger or equals to 0, giving us x bigger or equals to negative 1. So the range for my f inverse x is x must be bigger or equals to negative 1.
There you have the top 10 function questions and how to solve them. Remember at the beginning I told that I'm going to rank these questions based on 3 criteria? Well, the tactic to overcome difficult questions are in these 3 criteria itself: difficulty, psychology, and speed. Understanding the fundamentals and the correct methods will make the questions less difficult. Diversifying the types of questions we try will give us the confidence to face the exam psychology. And practicing over and over and over will give us speed. So these are the 3 things you have to do. Okay guys, I have to take a break next week, but I promise to be back with a brand new topic the following week. Please let me know what you think of my top 10 list in the comments below. And if you like this video and would like to see more videos like this, don't forget to click the like button and subscribe to this channel. I'm gonna leave you with some function memes to lighten up the mood a bit. See you guys in the next video. Bye.